So let's go on with our discussion of creational design patterns. That is, the design patterns that have to do with the creation of objects, of course. And very clear and simple one is actually the builder pattern. What you're seeing here is the UML diagram of the builder pattern. Let us actually read its definition straight from the Bible, from the Gang 4 book on design patterns. And here's the definition. So hold on and read it with me. Separate the construction of complex object from its representation so that the same construction process can create different representations. What? So, well, the Gang 4 book is actually a very good book, but it suffers from a very abstract terminology. It's very terse. It's actually way too terse than it actually needs to be. But I guess we can forgive them for this, because I guess those were in a way, the pioneering years of object-oriented programming, and I guess that to sell it better to management and enterprises, they sort of had to make it sound like it was rocket science, while it actually isn't. It's very simple stuff. Object-oriented design is very natural, very intuitive stuff. But let's try to understand what this is saying. Well, we are interested in constructing objects that are pretty complex, and so just invoking a constructor won't cut it. Why it won't do it? Because I would have, if I did it with the constructor, I would have to pass a ton of parameters, and then it would be hard for the caller of the constructor to be absolutely sure of the meaning of each parameter, and then maybe not all parameters are needed at all times. Makes sense for every creation, and so we need a better way to construct a complex object. And we also want a way to construct a complex object that allows us not to be too involved in the detail of its representation. Here, representation basically means its internal structure, exactly how it is constructed internally, and we don't want to know that because as we all know, in object-oriented design, ignorance is bliss. And if you don't understand what I'm saying here, it's the same principle that governs encapsulation, for example, another very fundamental and basic concept in object-oriented design. If you're confused about this, you can always watch my video on encapsulation. It's here in my channel. It's in Java, but I'm sure if you can follow basic C#, you can follow basic Java as well. So let's go back to our UML diagram. And here we see the classes that are involved in this pattern. Basically, there's an abstraction that could be an interface or an abstract class. In all of these design patterns, when we talk about abstraction, we don't really care if you're talking about interfaces or abstraction. We just mean something general, the mother of other classes, and then if it's through extension or if it is through implementation, we don't really care about it. It's just an implementation detail that will vary from time to time. So we define an abstraction that we call the Astral Builder, the builder, and this builder will have one or more method that allow us to construct the object. Usually it will be more than one, because if one method was enough, then we wouldn't need all this mess anyway. We just call a constructor and be happy with it. And then we'll have, of course, one or more, typically more, implementation or extension of this builder that have the responsibility of actually building different products. And in this pattern, there's also another class that's called a director. The director is actually the assembler, the assembler of the project, the one that knows the sequence or the algorithm that's necessary to build the object, but it doesn't know the details of the object. So during that algorithm, it would just call method on the on the builder that we pass to him. And as you see here, there's a composition. The director basically contains a builder, and we'll use this builder inside his method construct. When we invoke it, he will know the steps that he has to follow, but he will ask the builder to do these steps for him. And you should look carefully at this UML diagram and kind of burn it in your mind, because this is the stereotype for like 90% of design patterns. One funny thing about design patterns is that, as I said before, they are so like rocket science, and like especially junior developer are a little bit intimidated by them. But actually 90% of these design patterns are just different variation on this basic trick. That is composition. You see here's the director as a composition with the builder, composition of an object with a family of other objects. Here we say a family because we have, of course, a mother and then its children, which are implementation or extensions. So composition with a family of objects is the key to all class, not to all, of course, but like most design patterns. It's always the same stuff, basically, just in different context, and we can use this trick to solve different kind of problems, but I want to stress this, it's basically just the same solution over and over, and you see it as we go on with our exposition of design patterns. Okay, so let's actually start coding. So where do we start? Well, let's create first of all another directory. So add new folder, and we call it hardware because the first example that we'll see will be like little examples about representing how we build, for example, PCs or game consoles, pretending we have to execute the orders of some clients. Let's put an order for a PC or game console.